Today we're talking about solving absolute value equations. So there are 4 steps that you need to follow to solve absolute value equations. Step 1 is to make sure that your absolute value expression is isolated. So you want to make sure that your absolute value part of your equation is all by itself before you can go any farther. Step 2 is to set the inside equal to both the positive and negative number from the other side of the equation, and I'll show you what that looks like in a minute. Step 3 is to solve both equations. And step 4 is to write your answer as a solution set. And for example, a solution set looks like this here. Oh, that is not writing. There we go. All right. So, examples. Number 1 is going to be an easy one. It's just the absolute value of x equals 2. So step 1 is to make sure your absolute value expression is isolated. And that just means that we want the absolute value bars here to be all by themselves. There's nothing being added to it, nothing being multiplied. It's just by itself. In this case, it is. So we're good. We can move to step 2. Step 2 is to set the inside of the bars, so x, equal to both the positive and negative number from the other side. So remember, with absolute value, when your answer is positive here, that means that the number inside is either the positive or negative version of that outside number. So when it's just like this, we're just going to do x equals 2 and x equals negative 2. All right, we have nothing to solve here in these equations. They're already totally solved for us. So we're going to write our answer as a solution set. So we have x equals, and then we have our braces. And we're going to write our smaller number first every time, and then the other. So if you can't draw that squiggly brace, that's fine. Just try your best. But you need to use the braces. It's not parentheses, it's not brackets. It is braces for this type of problem. So for number 2, you can try that one. Give you a quick second, pause it, come back when you're ready. So for number 2, it's the same idea as number 1. We're doing m equals. We have an isolated absolute value here, so we're done with that. We can go to step 2, which is to set the inside equal to both the positive and negative version of the outside. So since the inside is only m, we'll put m equals, and then we're going to have negative 14 and 14. So whenever we have that, we're going to go ahead and step 3, solve, and there's nothing to solve here. So step 4 is to write it as a solution set. And remember, we're writing the smaller number first. All right, so that's it for that kind. So now there are going to be more difficult problems, obviously. For example, number 3 has an extra step now. So we're going to go ahead and solve that. So step 1 is to make sure that our absolute value expression is isolated. And it still is. There's nothing being added or subtracted on the outside here, so we're good. So go ahead to step 2 and set the inside equal to positive and negative version of the outside. So I'm going to go ahead and put 5z equals, and then we'll do the negative version, and 5z equals the positive version. And now step 4 is to go ahead and solve both equations. So to solve this, I'm going to divide by 5. Same thing on this side. So I have z equals negative 8. And then over here I have z equals a positive 8. And then I have my 2 solutions, so I'm going to write it as negative 8, comma 8 with my braces. All right, so number 4, pause it, try it, come back when you're ready. For number 4, same idea, we're taking step 1 is to make sure we have this isolated, and we do. So step 2 is to set the inside step equal to the positive and negative version of the outside. So we have 7, or negative 7a equals 28, negative 7a equals a negative 28. It doesn't matter which one you write first, the positive or the negative, as long as your final answer is written with the smaller number first. So then step 3 is to solve. So I'm going to divide by negative 7. So over here, I have a equals negative 4. And then also divide by negative 7. And over here, I have a equals a positive 4. So then I'm going to go ahead and write my answers. A equals braces -4, comma 4. There we go. All right, so number 5. Step 1, make sure it's isolated. It is. Step 2, to make sure that we're going to go ahead and put this number on the outside as a positive and negative version set equal to what's on the inside. So d plus 1 equals 8. D plus 1 equals -8. Step 3 is to solve. So we're going to go ahead and solve this. So I have d equals 7, minus 1, minus 1, and d equals a -9. So then my final answer is d equals braces -9, comma 7. And that is my final answer for this one. So go ahead, pause, try number 6 on your own, press play when you're ready. So for number 6, step 1, make sure it's isolated. It is. Step 2, set the inside part equal to the positive and negative versions of the outside, which in this case is 4. Step 3 is to solve. So we'll add 3, add 3. So w equals 7 over here. Add 3, add 3. W equals -1 over here. So then our final answer, we write the smaller one first, and then the larger one. So you should have had -1 and 7 as your answers. Okay, so for number 7, we're going to go ahead and step 1, make sure it's isolated, and it is. So step 2 is to set the inside part equal to the positive and negative version of the outside number. So 4n plus 2 equals 34, and 4n plus 2 equals -34. And now we're going to go ahead and step 3 is to solve. So these are two-step equations now, so it's a little different than what we did up above. We're going to subtract 2 first. We have 4n equals 32. And then once we get our 4n equals 32, we're going to divide both parts by 4 to get a final answer of n equals 8. So let me hope this will catch up to what I'm saying. Okay, divide by 4, divide by 4. So n equals 8 for the left part. And then for the right part, we're going to go ahead and solve that. Same steps as we did here. But now we're going to just have a different final answer. So we want to subtract 2. And when we take -34 minus 2, we actually have -36. And then we're going to take our -36 and divide both parts by 4 to get n equals a -9. And then since our -9 is the smaller of the two, our -9 is going to be written first, and then our 8 will be written after that. Okay, so I just took a second and froze, but it should be -9 and 8. So I want you to take a second, pause the video, try number 8, and then compare it to what we get in just a second. Okay, so for number 8, you should have gotten v equals -11 and 6. Okay, so compare your work to what's here and see if you got the same answer. Okay, so those were all examples where there wasn't stuff on the outside of the absolute value bars. So what if there is stuff out there? So if there is, you want to make sure you're isolating your absolute value first. So in number 9, we're going to look at that. So we have our absolute value of c here, plus 2 equals 12. So the first step is to get that c by itself. And since we have plus 2, we're going to solve it like that's a grouping symbol and solve everything around it, and then we'll go back to that part. So we're going to go ahead and subtract 2 from both sides first in order to get the absolute value of c equals 10. And then we'll follow our absolute value steps where we set the inside part, c, equal to the positive and negative version of the outside part, so 10 and -10. And when we have that, we can't solve this one, so our final answer is c equals -10 and 10. Okay, so for number 10, same idea. We've got y, the absolute value of y minus 8 equals a -5. So the first step is to make sure we get rid of that -8. And we do by adding 8 to both sides. So we have the absolute value of y equals 3. And then you take the inside stuff, which is the y, set it equal to the opposite in that positive version of 3, so -3 and +3. And when you get your answer, you have y equals your braces, -3, comma, +3. Okay, so let's try something a little bit more complicated. So let's look at this one. 6 times the absolute value of x equals 24. So this is a multiplication because it's like a grouping symbol. So when you have a number outside of your grouping symbol, this just means you're multiplying. So to undo the multiplication, you want to divide. So you're going to divide both parts by 6 to get the absolute value of x equals 4. And then again, take that inside part and set it to the positive and negative version of the outside part. So x equals 4 and x equals -4. And then there's nothing to solve here, so that is our final answer. Okay, so I'm going to try to make it so you can't see the work. No guarantees here. Active inspires acting up. All right, so number 12, you can see down here it's -2 times the absolute value of z plus 3, close the absolute value, equals -14. So pause the video, try this one in this bottom corner, and then press play when you're ready. All right, so to solve this, the first step is to get rid of that outside stuff. So we have to get rid of that -2. So we're going to go ahead and divide both sides by -2 first. And then we're left with the absolute value of z plus 3 equals 7. Now we can go ahead and solve. So we want to take our z plus 3 and set it equal to 7, and then z plus 3 equals -7. And then once we have that, we can go ahead and solve it like a normal equation. So we're going to subtract 3 from both sides to get z equals 4 and z equals -10, depending on which one you're looking at. And there's nothing else to do there, so that's our answer. All right, so let's look at number 13. Number 13 gives us the absolute value of 2w minus 4 all over 6 equals 3. So you can see that they're multiplying by 6 first here. We're getting rid of that division part because we want to get the absolute value bars by itself. So in order to get the absolute value by itself, you need to multiply both sides by 6 to cancel out that denominator of 6. So on the left, you now have the absolute value of 2w minus 4, and you have equals 3 times 6 is 18. So now that we have our absolute value bars isolated, we can go ahead and solve. So we're going to go ahead and put it equal to the positive and negative version of itself. So 2w minus 4 equals 18, and 2w minus 4 equals a -18. And then we're going to solve. Add 4 to both sides, divide by 2. Do that for both equations. For the left side, you should get 11. For the right side, you get -7. And when you write your answer, it's w equals braces -7, comma 11. For number 14, just going to show you the whole thing. Okay, so we have a negative 10 times the absolute value of h plus 5 minus 3 equals a negative 83. So the first step is to solve this like you would a regular multi-step equation. So you can pretend, if it's easier, that stuff in the absolute value, you can pretend like it's a variable, and you're trying to isolate that by itself. So we're going to use the same steps that we do when we're solving equations here to solve this problem. So when you're solving an equation, remember you're doing the order of operations backwards. So we want to do the same thing here. So you can see their very first step is they're adding 3 to both sides. You need to get rid of that subtraction first before you can get rid of the multiplication. So we're going to go ahead and add 3 to both sides, where they get negative 10 times the absolute value of h plus 5 equals negative 80. And now you can go ahead and get rid of that multiplication. So to get rid of the multiplication, you need to divide by negative 10 on both sides. So then you're left with the absolute value of h plus 5 equals 8. The absolute value bars are now isolated, so you can go ahead and solve. So we have h plus 5 equals 8, and h plus 5 equals negative 8. Subtract 5 from both sides, and then there's nothing attached to that h, so once you subtract the 5 from both sides, you are done. So your answer is a negative 13, comma 3. All right, for number 15, same idea. Okay, we've got multiple things happening here. We're trying to get that absolute value part by itself right here. So we want to go ahead and get rid of our minus 6 first. And to get rid of our minus 6, we need to add 6 to both sides, like you see here. Once we add 6 to both sides, we're left with 7 times the parentheses, both times the absolute value, 4n plus 8 equals 112. So now that we have this, we need to get rid of this multiplication. That's why we're dividing by both 7s here. So we have the absolute value of 4n plus 8 equals 16. At this point, our absolute value is isolated, so we are good to continue. So we have 4n plus 8 equals positive 16 and negative 16. So we can go ahead and solve by subtracting 8 and then dividing by 4 like you would a normal two-step equation. When you solve, you should have h equals 2 and h equals negative 6, or n. I'm sorry, I don't know why I keep saying h. It is an n. So n equals negative 6, comma 2. And make sure you're writing that negative one, the smaller number, first. Okay, so this one looks scary with some fractions. So in this problem, same idea as what we just did. Get rid of the minus 24 first, because we want to try and isolate our absolute value. So we're going to subtract 24 from both sides, or add 24 to both sides, because it's the opposite of the subtraction. So plus 24 plus 24. Okay, so now I have 3 halves times the absolute value of 4r minus 4 equals 3. So you're going to see that they are multiplying by 2/3 here. And you should recall that when you're trying to get rid of something when you're multiplying by a fraction, we're not going to divide here. You want to multiply by the reciprocal. And remember, the reciprocal is just the flipped version of that fraction. So the reciprocal of 3 halves is 2/3. And when you take 3 halves times 2/3, that is going to make it equal to 1. And that's the goal here. So we want to do the reciprocal of 3 halves. So that's why we're multiplying by 2/3 on both sides. So that'll get this eliminated to 1, so we're good. There's nothing here. And then 3 times 2 is 6, and 6 divided by 3 will give me 2. So I'm good here. I'm going to go ahead and solve this. So 4r minus 4 equals 2, and 4r minus 4 equals a negative 2. Go ahead and solve. Add 4 to both sides. Divide by 4. And it's okay if you got a fraction. Make sure it is in simplest form. This would get you 6 over 4, which would reduce to 3 halves. And over here you got 2 over 4, which does reduce to 1/2. So make sure that you are simplifying your fractions before you write your answers. And keep them in improper fraction form. Don't change them to mixed numbers. Keep them as improper. So we have r equals 1/2, comma, 3 halves. Okay, so then we have one last section here. So there's special cases. So special cases, there are times where you're not going to have a solution, and that's okay. remember, the absolute value of something always has to equal a positive number. So for number 17, it says the absolute value of x equals -6. That's not physically possible. You cannot get a negative answer to that problem. If there was a negative sign out front here, then yes, that would be fine. But there isn't. It's just the absolute value of x and then -6. And that's not physically possible, so we would write no solution or put the null set symbol there. Okay, and then for number 18, you want to go ahead and start solving this. And we have our -3 times our absolute value of 2x plus 1 equals 21. So we're going to go ahead and divide both sides by -3. And we do end up with 2x plus 1 in the absolute value equals -7. Again, this is saying the absolute value of something is equal to a negative number. That is not physically possible. Okay, so if you get this far to where you have the absolute value by itself, and then you have a negative number over here, your answer is no solution. There is no physical way you can get this answer. So you would, again, put the no solution symbol like you see here. Okay, and the absolute value cannot equal a negative number once it's isolated. Okay, so there are times where you will get no solution, but most of the time you should have two solutions. You may even come up with a case that has one solution, but absolute value for the most part is going to get you those two solutions or no solution at all.